What is going on, team? It is your friend Austin here with APSpace, and today we are going to configure the GPIO for an STM32F1 on custom hardware. So if we go over to CubeMX, we're going to show you guys how to begin the process. So we click on the CubeMX application, go to File, New Project. We copy and paste our part number over that we're using, and then we double click on our part number, and this is the layout. And then once you have the pin layout, you go to File, Save Project As, and then to save the project wherever you need the project to be saved. In our case, we go to Load Projects, and then we load an existing CubeMX project, and this is what the layout looks like. Okay, so if we're configuring the GPIO, we just go to pin 12. It was already configured for GPIO. Pin PB12, we just put into the reset state. If we want to turn the pin or configure the pin to a GPIO, then we go to GPIO out. Okay, so PB12 is now a GPIO output. Another note is that the JTAG is a 4-pin JTAG. So you can either do a 4-pin JTAG or a 5-pin JTAG. Either one works just fine. We have a 4-pin JTAG, so that is also what is configured for this particular setup. So here's all our timing configurations. We can pretty much just leave that as default for the sake of the video. Now we are set to MDK-ARM if you're using Keil IDE. And then this is all of our project file locations, and now we can simply just go to generate code. And then we open project. And then we have our project folder, okay? And then everything that we need to configure is all in this while loop here, okay? So really where we could write everything is either in this while loop if the script needs to configure the GPIO on and off multiple times. If not, you can configure it somewhere in int, depending upon your application. So now if we want to set the pin to logic 1 or high, we go to HAL GPIO write pin, GPIO B, GPIO pin 12, GPIO pin set. We have a delay here, and then if we're turning the pin off or to logic 0, we go to HAL GPIO write pin, GPIO B, GPIO pin 12, and GPIO pin reset. And then we have another delay loop. And then that is just how you turn GPIO on and off somewhat quickly on an STM32F103, and it's pretty much as easy as that. So once you write in this block of code here into your while loop under the user code begin 3, so that when you recompile in CubeMX or regenerate code, your code won't get deleted. So if you put your code underneath the user code begin 3, your code will be saved essentially if the code is underneath this particular line. So now if we're compiling, then we need to edit one thing that's usually not configured correctly. So when we go to target, sometimes there's an error that pops up in Keil IDE, And what fixes the problem is you go to target, use default compiler version 6. And then here's just some of the other settings. You can just kind of peruse through here, and then that's kind of where a lot of the settings are. And then we rebuild, or you can build. This is the build button. If you just want to go build, we can build there, and then we click download, and then all of our programming is successful. So programming done, verify OK, Photon 2 can successfully be programmed. So I have Photon 2 plugged in right next to me here, and now that we have programmed the GPIO, I'll show you the pinout. Okay, so this is the connector here, and then if we go to the layout, then the plus 3v3 pin goes here. We have the 2 ground pins, and then we have the JTMS, JTCK, JTDO, and JTDI. And this is essentially our pinout and how we plug everything into a custom piece of hardware. The other thing to note is that when you're creating something that can actually be programmed, and if you're making a custom piece of hardware, you need a pull down resistor that's a 1.5K on JTCK, and then you need a pull up resistor on your JTMS and your JTDI. So this is a verified piece of hardware that can be configured with, or can be programmed successfully with these pull-up resistor values and these pull-down resistor values. So if you have any questions of verification, this has been done on real hardware. So this is how you do the external pull-up resistor so that everything can be programmed. There's supposedly internal pull-up resistors on all the, or most of the STM32 series for the F series. This probably helps with your signal just a little bit, just because you're getting a slightly faster response, and you're probably will have less errors here, and this is just helping the communication and the programming. So once again, pull-ups are here, and then your pull-down is here for your custom hardware. So what else do we have? That is pretty much it. It's just this block of code, and that is how you program GPIO on STM32. Everyone have a good one.